differentiate the bracket, which is a minus 2, so divide by minus 2. The sign here is times. Now it's easy, you know what to do next, right? That's a plus sign, so 3 times 2, 6. 5 over 6, bracket to the minus 3 there. It's 3 minus 2x and plus c. You want to remove the minus, bring it back to the denominator as they did here, you can. Okay, last one. You already have done a few sums of that type. E to the something is e to the same thing, no change, and we need to differentiate that. We get minus 2, so we divide by minus 2 or times by a minus half. Okay, done. Now these are the questions based on standard functions. So write those rules, 6 or 7 or 8 rules on one page, big in size, keep in front of you when you solve these sums. Also the sec, cosec, cot, very, very important. Then a reverse of the chain rule. Okay, don't forget them, please. We finished the first part. Now we look at the second one, which is trigonometric identities from C1, C2, C3, even C4, right? Write all those rules also at one place and then we solve those sums, right? Before you watch this, make sure you have that page in front of you, right? So how to integrate using trigonometric identities is now part 2, right? Tan square x or tan square theta. What I want you to look at the list of integrations that we know are here, right? Trigonometric ones, right? Those are the ones. We know sine, cos, squares wise, we know sec square, cosec square. We don't know any other. So we don't have sine square, we don't have cos square, sec square, cosec, okay, cot square, no. So our job now in this topic is to find the integration of all different types. So tan square is not a standard function. That's why we are trying to integrate this now using trigonometric identities. Identities, are you ready? You have on the paper written there, right? If you don't, it's difficult to solve, please, right? There we go. I have those 3 fundamental identities. We are in here. 1 plus tan square theta is sec square theta. Because I don't know tan square theta's integration, maybe I change that as sec square theta minus 1. Then I know that the standard form is there for sec square. Okay, so that's the idea. So what we do, change that as sec square theta minus 1. Integration d theta. First a few sums, slow, right? So there is a minus sign, separate terms, so I can integrate both of them. That's a standard function. Integration of sec square theta is tan theta. Listen, that's just a theta, so there is no chain rule here. If it's a 3x or 4x, then you may have to apply the chain rule, the reverse. Minus integration of 1 with respect to theta is theta and plus k. Okay, so actually we found a rule for integration of tan square. So you can remember them as integration tan square is tan theta minus theta plus c. Okay, now look for cot square now. Cot square is, do we have any identity for that from C3? Yes, we do. 1 plus cot square theta is cosec square theta. And immediately, cosec square theta is a standard function. Okay, so let's write that down. That's 1 plus cot square theta is cosec square theta, please. So that should be cosec square theta, which is a 2x minus 1. Okay, integrate bracket dx. That's a standard function. Cosec square theta integration, please, minus cot theta. Theta is a 2x. Differentiate, right? You get a 2, divide by 2. Very important. Because it's not just x, you are supposed to differentiate and use the reverse of the chain rule. minus integration of 1 is x. That's all plus c. So the first two questions, not bad. We just used the basic three identities and we solved them. The next two are very interesting ones. Integration of sine square. Now squares wise, as I said, we got only two squares in standard form. Sec square, we know the answer. Cosec square, we know the answer. But in standard form, we don't have the rest of the squares. So let's see how we do this. Sine square theta. We need to go back to C3 again, or C4, whatever. Try and see the double angle rules for cos theta. Say cos 2 theta is, there are three formulae. I'll just write the second two. It's 2 cos square theta and minus 1. That's the first one. What I want you to do is make cos square theta subject from here. So if you make cos square theta subject, you get half plus a half cos 2 theta. That's what you get. Transfer the 1 and then 2, done. Then there is a second rule for cos 2 theta, which is 1 minus 2 sine square theta. As I said, please write them at one place, right? This is also equals to cos 2 theta. Now make sine square theta subject. I don't waste much time in making theta subject. I mean, you all know. So sine square theta, if you make, you will have half cos 2 theta, and then you will have a minus half, right? That minus comes here, transfers there, that minus, so becomes a plus. This becomes minus, sorry. It's a 1 minus. So it's a half minus half cos 2 theta. These are very important rules for you to remember. Half minus half cos 2 theta is sine square, right? Half plus half cos 2 theta is cos square, right? So when we integrate the cos square, you can write it like this and integrate. For sine square, write it like that, integrate. Okay, so I'm taking you through the first one. Sine square x. So sine square x is nothing but half minus half cos 2 theta. Okay, that's what we proved just now, and dx. Now there are two terms there with a minus, you can integrate. So integration of half with respect to x is half x. Okay, minus half is a half, sorry, that's x, please. Now cos theta integration is sine theta. So let's write sine theta, but is that a theta? That's a 2x. So differentiate that, you get a 2, divide by 2, right? Instead of multiplication, that's a times, please. Done, and then say plus c. So we have a half x minus a quarter, that's not 22, right? Sine 2x and plus c. Okay, so for sine square and cos square, all that we do, we write them in terms of the double angles of the cos 2 theta, and then we integrate. Cos square x, I will leave that to you. Write this as cos square theta is a half plus half cos 2 theta, right? The other one I want you to notice, I'd like to spend a little bit more time, right? If this is a theta, that's 2 theta, double angle. If this is going to be 3x, for example, that will be double to this, and that's a 6x. Okay, so if someone asks you, say integrate, we have cos square 3x, right? So we go back here, we know the basic one, cos square theta is half plus half cos 2 theta. So that's a 6x now, isn't it? If theta is 3. So we write this as a half plus half and say cos 6x. That's what we are going to integrate. That's what it means. So don't just stick to theta and 2 theta. That's always double this, or this is a half of that. So can I leave this question with you? You can do it, right? That's the cos square. Done. Now we will be looking at a few more. The next one on the screen for you, which is sin x cos x dx, right? Double angles, please. Let's go back and then check. Sin 2 theta. Sin 2 theta is 2 sin theta cos theta. That's not in standard form, but if I write it like this, this is a standard form, which is sin theta like. So that's what we are going to do now, and say, if I introduce a 2 in front there, a 2 in front, that looks like 2 sin theta cos theta. We can write that as sin 2 theta, right? Because we introduced a 2, we multiply by a half, right? There must not be any change in the original question. Do whatever you like, right? Mathematically, the structure must not change. So now that becomes half is a half. 2 sin x cos x is sin 2x. That's a C3 rules, right? Trig rules. And then dx. Now we know we can just call this as theta, and that's a standard function. We can integrate that. So I have the half there. Integration of sin theta is minus cos theta. Watch, theta is at 2x. And don't forget, it's not just x, 2x. So differentiate that, you get a 2, divide by 2. So the answer is now minus a quarter cos 2x and plus c. That's how you leave the final answer. So you are allowed to introduce a few numbers as long as you do not make any changes in the original question. So here actually if 2 is gone, there is no change in the sum, right? That's the idea. Sec x plus tan x whole square. They are not standard form, right? So because there is a square, let's just expand it and then see what we get. Okay, so I'm going to expand a plus b whole square. So it should be sec square x plus 2 sec x tan x. You know how to open those brackets there, and tan square x. That's all. So we got 3 terms there. Now that's integration bracket and then dx. I mean, there are many ways to do, but sorry, our aim in this topic is to use the trig functions. So sec square, is that a standard function? Standard function? Yes, sec square. Sec x tan x? Yes. Tan square? No. But we found the tan square rule. Do you remember that? We just did tan square, tan theta minus theta. So that's what comes back. All right. So all the 3 are nice now. So integration of sec square is tan x. No chain rule there. That's just a x nicely. 2 is a 2. Integration of sec x tan x is sec x plus integration of tan square theta is tan theta minus theta. Watch. So let's write that. It's a tan theta minus theta. Okay. Or you change that to sec square minus 1 and then you can do that. And plus c please. Any like terms? Yes. 2 tan theta. 2 tan. This is all x please. I'm sorry. Yeah. 2 tan x plus 2 sec x and then plus c. You can leave it. I mean, it's a sine over cos, 1 over cos. If you want, you can simplify the fractions there. But I just want to try and explain how to apply these trig rules. Done. That's question 6. Question number 7 is on the screen. That's cos to the power 4x dx, right? There are 2-3 methods of solving this. One of them is like this. Let's write cos to the 4 as cos square x and then a whole square. Dx comes back. So now we convert the cos square theta into the double angles of cos theta. So that comes down as, we all know, we have done that once, right? So that's a half plus half cos 2 theta That's what we had, of 2x. And then we have a whole square and dx in the end. So what we are saying now is, okay, we wrote cos square in terms of the double angles. Now we expand the bracket. After the expansion, we are supposed to get half square, which will be a quarter, and then plus that square, which will be a quarter cos square 2x. That's what we will get. And then plus 2ab. So that should be, I think it's a half and cos 2 theta. So what happened now? Well, there is a bracket and there is an integration sign. So I will put that right at the end. Once we got to that stage, we can integrate 1 over 4, we know. We can integrate half cos 2x, cos theta, fine. But this is a cos square theta, so we have to change this. This we cannot integrate like that. So write the quarter as a quarter, and plus that quarter comes out, and inside the bracket, the cos square 2x now, we apply the same rule that we have here. But watch very carefully, if that's a x, we have a 2x here, double angle. If that's a 2x, we will have a 4x, right? So cos square 2x is half plus half cos 4x. That's what we will get. So that's the double angle form of the cos square 2x, and then we have the last one, which is plus half cos 2x. Now we are happy. We can integrate everything now, right? So we can open the brackets and integrate. That's the next bit now. So a quarter comes as a quarter. Just open the bracket with this 1/4. So that should be 1/8. And then another 1/8 there. Cos 4x, please. And then we have a plus. Half is a half and cos 2x. So that's what we end up getting, right? Now, just collect the like terms before we integrate. There is an integration sign, please, okay? That's a 2, so 3/8 will be there, 3/8, and then plus 1/8 cos 4x, and then we have plus half cos 2x. So not bad. So all these three terms now can be integrated. Okay, that's a dx in the end and integration sign. Integration, please, of 3 over 8. Integration of 3 over 8 is 3/8 x, isn't it? With respect to x. So 3 over 8x plus, we use the chain rule, the reverse, so the 4 comes down. So it's a 1 over 32 cos theta. Integration is just a sine theta. So that's a sine 4x. And then plus reverse of the chain rule. So 2 comes down. That's a quarter cos 2x. Sine 2x, isn't it? Integration of cos is sine, please. So those are the three, and then say plus c. So that's how we integrate the cos to the power 4. There are many ways, but this is one of the methods. So all that we did was we simply wrote cos to the 4 as a cos square and a whole square, changed that into double angles of cos theta, and then expand the bracket. After that, everything is fine. Just be careful. If that's a 2x there, if that's a 2x there, we are supposed to get a 4x because it's the double angle, right? So I have question 8, which is sine to the power 4x. I will leave this question with you. You solve that, but apply the same method that we did in the last one. So simply write that as a sine square x and then a whole square. You know how to write sine square x in terms of the double angles of cos theta, right? Half minus half cos 2 theta, square it, and it will be same, exactly same style. All right, so I will leave that question with you guys. Then number 9 is here. That's sine 2x times cos 2x. Once again, double angles, like it's a sine theta, cos theta. We have a rule that says, we all know, sine 2 theta is equals to 2 sine theta cos theta. Sine theta cos theta. So what we do, if we have something like that, we introduce a 2 in the front, then that becomes sine 2 theta, then we can integrate this. Okay, so that's the plan. if that's going to be a 2 theta, that's 1 theta. If that's a 4 theta, it will be 2 theta. So that's a theta. Now watch. Okay, that's also theta. So sine theta, cos theta. We introduce a 2 in the front, and to validate that we have to multiply by a half there, right? Now the question looks like 2 sine theta cos theta, which is sine 2 theta. That's the double angles. So let's write this as half is in the front, and then that's going to be sine 2 theta. Please understand, 2 theta, 2 lots of that, so it's a 4x. Alright, so that's a 4x and dx there. We know how to integrate this now. Half is a half, multiplied by reverse of the chain rule. We get a quarter first, and then sine theta's integration, please, is a minus cos theta, so cos 4x and plus c. Then that's a minus an eighth, and we have cos 4x plus c. Okay, so just applying the double angles rule there, just be careful. Similar question, we have the next one on the screen. That's a 10th one now. Sin x cos x. So as I said, we have again sin x cos x. Introduce a 2, that becomes double angle of sine. To introduce a 2, one should be very careful how you do that. The bracket is there, suppose. If you put a 2 there, you can't multiply by half. It's a 2 square, isn't it? So it's a 4. So actually we introduced a new number called times 4. So we divide by 4. Right? That's all. Then it's going to be a quarter integration. That becomes 2 sin x cos x is a sin 2x. That's all. And there is a square. Of course, it's a sine square 2x dx. So we are back to sine square theta. Right? Sine square theta. We are supposed to write that in terms of double angles of cos. For sine square, it's going to be half minus half, right? So that's a quarter integration inside the bracket. Half minus half cos 2 theta, watch. Cos 2 theta is 4. That's what happens. Then we have dx. We did not integrate yet, okay? Now we can integrate. So that's a quarter, which is outside the integration sign. So now I'm going to integrate this, right? Half with respect to x is a half x, and minus half is half. The 4 comes down, so it's an eighth. Integration of cos theta is a sine theta, so that's a sine 4x. Done. And plus c. Now we open the bracket with the quarter there, so that's an eighth x minus 1 over 32 sine 4x. That's what we have, and plus c. So not bad. I mean, it's the same type of approach. Introduce a 2 there. Just be careful. It's a whole square, so 2 square will become a 4. So multiply by quarter, that comes down. Right, that's 10th question. You can copy this sum, please. This is question number 11. Copy that down, solve it, and then you check the answer. Okay, so that's 10x minus cot x whole square. Our objective, please remember, is changing everything into the standard functions, okay? So standard functions are here, we know, sine cos x square, cos x square. So we are supposed to get one of them so that we can find the answer. Integration, I got a bracket and a square. 2-3 methods or two, three ways to do. Let's just open the bracket and see what happens. So integration, and it's a tan square x plus cot square x, right? So that's a square plus b square minus 2ab. So that's going to be 2 tan x cot x. Tan x cot x. And then bracket is closed. There is a dx, right? We know tan theta times cos theta. Tan is a sine over cos, right? And cot is cos over sine. So those two actually cancel out, and we get a 2. Now, integration of tan square I don't have, right? So I have sec square integration. So we can write the rules that we know from C3. There we go. I told you, copy them at one place, please. So I know the integration of sec square. I am with tan square. So write tan square as a sec square minus 1, see what happens. So that's going to be sec square x minus 1. In the same way, we don't have integration rule for cot square, but we do have for cosec square. So let's